Okay, this is part two of this chapter 6 on environmental quality. And this section is most likely going to be mostly about air quality, and there's a lot to it. So, air quality. Air quality is subject to both natural and human influences. So, we talked a little bit about both natural and human influences. Your book calls it anthropogenic influences. Natural pollutants are gaseous emissions from the earth, volcanic ash, pollen, and methanes. Um, we on the Big Island have had a lot of natural air pollution, otherwise known as VOG, but that is just as polluting as the carbon dioxide that would come from human-generated activity. Now, ambient air is the air that surrounds us. And there's been a lot of instances of critical ambient air pollution. Your book talks about 2013 when the ambient air quality in Beijing was so poor that school children and the elderly were forced to stay indoors. There was a big incident in 1952 where smog killed nearly 4,000 people in London, England, and that led to the UK Clean Air Act. We in the United States have had lots of instances of quote unquote bad air days. I remember growing up in the Los Angeles area in the 1970s, and there would literally be smog alerts. And with those smog alerts, we citizens would be advised to go indoors so as to not to breathe the dirty air. Now, this led to, in 1970, the passage of something called the Clean Air Act. And in the Clean Air Act, the EPA, or the Environmental Protection Agency, set up the National Ambient Air Quality Standards for 6 criteria air pollutants considered harmful to public health, welfare, and the environment. Now, primary standards are standards designed to protect public health. And secondary standards are designed to protect public welfare. So these are standards that are set up by the Clean Air Act. And you can see Table 6-2 and Table 6-1, which talk about the ambient air quality standards that are indeed set up. Now, the actual levels of air quality. There are 4,000 air quality monitoring stations across the United States. And states must submit their air monitoring data monthly for inclusion in the EPA's Aerometric Information Reporting System. Now, Table 6-3 is this the same? Actually, it would be 6-2 in your 5th edition. Says the population exposed to non-compliant pollution levels in the United States, and this just shows the number of people living in the non-compliant counties. Now, if there's non-compliance, the EPA can do different sanctions, and your book talks about a 2-for-1 offset sanction for every one increase in pollution, the offending agency would have to decrease their offset their pollution by a factor of 2. Over the past 2 decades, the EPA has sent out hundreds of formal notifications of intent to apply sanctions. Most counties remedy the problem within the 18-month period between formal notification and the imposition of sanctions. Okay. Now, acid disposition is commonly referred to as acid rain, and this occurs when rainwater, fog, or snow has reached a pH level lower than 5. And that has definitely happened, especially with the advent of coal-fired power plants, um, followed by industry and road transportation. Now, the coal industry could install coal scrubbers, but those are very, very expensive. There's been an innovative approach to acid rain involving tradable pollution allowances, and that has indeed reduced the annual sulfur dioxide emissions in the United States by about 10 million tons. Acid rain is a case of um, a uniformly or a non-point source pollution that comes from several different sources, and acid rain can drift over from, let's say, plants in the United States to population centers in Canada and all around the United States. So tradable pollution allowances adds a market mechanism to this and has decreased the amount of acid rain in the United States by, as it says here in the book, by about 10 million tons. We'll talk about this in greater detail in chapter 12. Okay, now if that wasn't big enough, we've got the big biggie, global climate change. This is the most prominent result of air pollution in the 21st century. And there's definitely carbon dioxide and methane concentrations that have more than doubled, and carbon dioxide has certainly risen by nearly 30% since the Industrial Revolution. And Intergovernmental Panel on Climate Change has made a number of conclusions that warming of the climate system is unequivocal, and that it comes from human beings. This warmth is unusual, at least during the last 1,300 years. Last time polar regions were significantly warmer than they are now, about 125,000 years ago. Reductions in polar ice volume led to a 4 to 6 meter rise in the global sea level. That would be meter rise, so that would be about maybe 12 to 15 foot rise in the global sea level. So this is serious, serious business. And there is a warming of about 0.2 degrees Celsius per decade for a range of emission scenarios. And these impacts are caused largely by humans burning fossil fuels. And the EPA reports that scientists are confident that many of the observed changes in the climate can be linked to an increase in greenhouse gases in the atmosphere caused largely by humans burning fossil fuels to generate electricity, heat, and cool buildings and power vehicles. And global warming has led to more deadlier storms. This is Hurricane Katrina, approximately 2005, and this was a Category 5 hurricane that headed towards the Gulf of Mexico and caused undue damage in Louisiana and New Orleans. Hurricane Sandy, which was in the year 2012, caused an enormous amount of damage, $60 billion worth of damage in 2012, and that hit the New York, New Jersey seacoast area, and especially had an impact upon low-lying areas in Long Island and New York. Subways were flooded. Coastal communities were absolutely inundated by the storm Hurricane Sandy. The same thing happened with Hurricane Katrina. This is a slide that shows, this is from the previous edition, shows the projected temperature change in the year 2000. As you can see, temperature change in Celsius in the year 2020 about 1%, but if the progression proceeds as it is currently, we're going to be above 2% in 2040, over 3% in 2060, and all the way up to over 5 degrees Celsius in the year 2100. Not very good at all with regard to this global climate change. Okay, I do believe this ends this section. The next section we'll talk about water quality.